Hello guys, welcome to another video, and in this video we are going to talk about some physics. Okay, so we're going to talk about distance, displacement, speed, velocity, and just a little introduction to physics. We're going to talk about acceleration and scalar and vector quantities. Okay, so the first thing we have is we're going to talk about distance. Okay, what is distance? Well, distance in physics is a scalar quantity. Okay, and distance is always going to be measured in positive. Okay, so it's always going to be a positive number. Okay, because distance is it's kind of like the absolute value of something. It's never going to be negative. It's always going to be positive. Okay, you cannot have a negative distance. Okay, now let's think about what displacement is. Okay, so displacement is actually something very important in kinematics and physics in general. Okay, so displacement is a vector quantity. Okay, and displacement can be negative or positive depending on how it's being implemented. Okay, all right, so guys, so let's see, so what are scalar and vector quantities? Okay, so let's make a little graph or a little table. Scalar and vector. Okay, scalar is basically something that has no direction. Okay, so it's a quantity that has no direction to it. Okay, so no direction. The direction doesn't matter. When you have distance, say you're walking from home to a school, and that's what? Let's say that's 40 meters. That's the distance. It doesn't matter if you went west, east, north, or south. For distance, direction does not matter, and that's why distance is a scalar quantity. Scalar quantities are quantities that don't care about direction. Okay, they are all about the magnitude. Okay, the magnitude of something is just how much. Okay, so it's just 40 meters, that's the distance, and it's just 40 meters. Okay, now let's look at vector quantities. Okay, so vector quantities are things like velocity, displacement, acceleration, and many more. Okay, but for now, let's just focus on velocity, displacement, and acceleration. Okay, so here direction does matter. Okay, so for example, we're going to talk about displacement in a bit, and in displacement, velocity, and acceleration, we do need to understand if the object that's moving is going north, south, left, right, east. You get the idea. Okay, so these vector quantities include magnitude and direction. So they have both. Okay, all right. Okay, guys. So let's take a look at at a person. So let's say we have a person. Say this is you, and you want to walk. Say you want to walk here, and then you walk over here, and that's 10 meters. and this is down 2 meters. So you went, let's say you went east 10 meters, and then you went south 2 meters. Okay, so if we were to calculate the distance of this person walking, we would have 12 meters, right? Because in total it's 12 meters. And we have a positive value because distance is always positive. Okay, so it's just 10 plus 2 is 12 meters. Okay, now let's think about displacement. Okay, so displacement, as we've seen before, is a vector quantity. Okay, so let's make a number line. So let's see, we have 1, 2, 3, 4, 5. Here we have -1, -2, 3, and -4. All right, so let's say this is our starting point here, 0. Okay, and let's say we walk 3 to the right. Okay, so we do 3 to the right, or east, if you want to call it like that, right? But then we decide we want to go back, and we go down to -2 right here, and we stop at -2. What would be the distance and displacement of this problem? Well, the distance is pretty simple. For the distance, here, we just have to calculate the total amount of meters, centimeters, feet, whatever, that they walked, right? So here, from 0 to 3, we have 3. Then we go back to 0, so that's 6. And then we go back another 2, so that's 8. So they walked a distance of 8 meters. Okay, now what is the displacement? Okay, so we know that the displacement is a vector quantity, that direction matters with displacement. Okay, so so let's see what we have here. So if it went 3 to the right, and then it went, what, 3, 5, right? So it went 5 to the left. What is the displacement of this person or of this object? Well, the answer is -2. And the reason why it's -2 is because displacement is just the distance from the origin, or from the starting point, to the final ending point. So because this object ended at -2, the only thing we would need to do is just -2 from 0 is 2, right? So that's the distance. But the displacement, remember, is a vector quantity, so we care about direction. So it ended up going to the left, right? It ended up going to the left because of the arrow, right? So that means that when we're going to the left, we're always going to associate the left with a negative number. When we're going west, we're associating that with a negative number. Same as south. South is always negative. Right is east is always going to be positive. North, up, is always going to be positive. Okay, so in this case, it's going left, so it's going to be negative. Now guys, let's think about speed. Okay, so what's speed? Well, speed, it's actually a scalar quantity. Speed does not care about direction. It only cares about magnitude. Okay? So it doesn't care if you're going left, if you're going right, if you're going up, if you're going south. It does not care. It's just, speed is just how fast something moves. Okay? So if you have a car that's going at 30 miles per hour, then that's the speed. If it's going at 30 meters per second, that's the speed. Okay? So, all right, so we're gonna have this little equation here to find speed. Okay, so distance equals velocity or speed. This could also mean speed. It just depends what you're solving for. Times time. So this is either distance or displacement. This is or speed or velocity. And this is just time. Okay? So let's have an example. Let's say we have let's say we have an object. And this object right here is moving at 50 meters per second. And it's going to the right, of course. Now, we want to find out um, how long it takes for the object to reach 1,000 meters. Okay, so the distance of the object is 1,000 meters. Okay, now we know the velocity or the speed in this case, because we're basing off of speed. So the speed is going to be 50, right? 50 meters per second. So using this equation right here, well, how would we solve for the time? So how long does it take for this object to travel 1,000 meters? Well, let's just solve the equation here. And it's going to be 20 seconds. So that's our answer for this problem. Alright guys, so now let's take a look at another example. Alright, so let's say we have an object here that's moving, say it's moving south 45 meters per second. Okay, so what would be the velocity with direction, of course, because it's a vector quantity. What would be the velocity of this object? Well, it's simple, 45 meters per second, but it's negative 45 meters per second because it's going south. Remember, always associate south and west or left with negatives. Okay, all right, so now let's say we have an object here and it's going west at 15 meters per second. It's going west. And it's been traveling for about 10 seconds. Using the formula that we know, displacement or distance equals velocity times time, what would be, or how long, how much has this object traveled with a velocity of 50 meters per second in 10 seconds? Well, let's see. Of course, we have added direction into this problem, so we know that we're going to get a vector quantity. We're going to have velocity in this case, not speed. Okay, that's the difference between velocity and speed. Velocity is a vector quantity with direction, and speed is a scalar quantity that doesn't matter direction. Okay, so in this case, we're going to have displacement. So we're going to be solving for the displacement of this object, not the distance. We would have used speed if we wanted to do the distance. Okay, there is a difference. Okay, so all right, so let's see. So we have velocity is 15 times the time, which is 10. So the displacement of this object is going to be 150 meters. Now, since this object is moving west, the displacement is going to be negative 150 meters. You could also write this like 150 meters west. Okay, so this is the displacement of this problem. Okay guys, now we're going to be learning about graphs. Okay, so the first graph we're going to be looking at is a position versus time graph. Okay, so first off, we need to understand that we need to understand that displacement is the change in x. Okay, so displacement is just a change in x, because remember back in the number line, it's really just the change in x, right? So it's just how much the x-axis in this case is changing. So for displacement, we usually represent displacement as change in x. So even if you don't see a d, for example, you might see a change in x, or a triangle and an x, which just means the displacement of an object. Okay, so that that's just something we need to understand. Displacement is the change in x. Okay, so this position versus time graph here, the slope of this graph, of this linear function, of this line, is going to actually give us the velocity. Okay, so this position versus time graph gives us the velocity of the object. So let's say we have an object that starts from rest, and then it keeps changing its position over time here, right? So to understand this, we need to really understand what slope is in this case. Okay, so slope here is just the change in x over the change in time, or displacement over time. Okay, so we need to understand that velocity is a vector quantity. Displacement is also a vector quantity. So from displacement, you can derive velocity. Okay, so displacement over time, or the change in x over time, is just velocity. Okay, guys? So really just understand that when you have a position versus time graph, it's going to give you the displacement, right? But it's also going to give you the velocity, okay? When you find the area, for example, so you find the area of this triangle right here, you're actually going to get the displacement when you find the area. Now, when you find the rate of change of this line, you're going to get the velocity. Now, let's say we have a velocity versus time graph. Okay, so this one's going to be a velocity versus time graph. Now, what is this graph going to tell us? Well, if we have a line here, the rate of change of this line is going to give us the acceleration of this object. Okay, so really just remember, a position versus time graph gives you the velocity, which then you can make a velocity versus time graph. Okay, so if the velocity is increasing, then that means we have a positive rate of change, which means we have acceleration. So in this case, the object is accelerating. Now, what if we were to have a constant velocity? So let's say you're driving your car and you're constantly driving it at 30 miles per hour. Well, that would be a constant speed or a constant velocity. In this case, we're using velocity. So you have a constant velocity of 30 miles per hour. You're not changing your speed. Okay, so when you have a constant velocity, what is the slope of a horizontal line that crosses the y-axis? Well, the slope is 0. And when the slope is 0, that means there is no acceleration. Okay, now of course, if the velocity is increasing, so let's say you're driving your car and you're going from 5 miles per hour to 25 miles per hour to 30 miles per hour to 60 miles per hour, right there you have a positive rate of change. So what's going to happen? Well, you're going to have acceleration. So in this one, you have the rate of change, which is just change in velocity over time, right? So when you have change in velocity over time, that's going to equal the acceleration of the object. Now, if we had a line that were to be going down, if you had a line that were to be going down, then you would actually have a negative acceleration because you have a negative slope. So in this case, let's say you start, you're in the highway and you're at 80 miles per hour. Let's say you start getting into it's a little bit of a city zone, and you start to decrease your speed over time. Well, you're actually decelerating. So you're decreasing your acceleration. You are accelerating, but you're decelerating. You're not going up. Okay, so the acceleration is decreasing, just like the velocity. Okay, so really just understand that from a position versus time graph, you get velocity because it gives you displacement. Okay, from a velocity versus time graph, you get acceleration.